Yeah, I don't need to do it yet. There's a exterior angle theorem. 1 is an exterior angle, and so it is equal to the sum of 3 and 4. In other words, it's equal to the two angles that it is not a linear pair with. And notice why. 1 is supplementary to 2, and 2 is supplementary to 3 and 4. So therefore, 1 is equal to 3 plus 4. Okay?
Yes.
All right. Is 1 equal to 5?
Yes.
No, not that we can tell. We don't know. They haven't, if it's an equilateral triangle, yes, but they haven't told us anything about that triangle. Not from the first few questions and not from the picture. According to the picture, we do not know that 1 is equal to 5. Okay?
Okay.
In other words, you can't assume that it's always drawn to scale. So number 3, if AB is congruent to AD, okay, then angle ABD is, what kind of a, or triangle ABD is what kind of a triangle?
Isosceles.
Okay. And if the measurement of angle 5 equals 118, then triangle BDC is what kind of a triangle?
Obtuse.
Yeah, I guess that's what they're looking for there. Yeah, that certainly fits. I don't know what else we could say about that triangle. We don't know if that triangle is isosceles. We don't know if it's whatever the name is when all three sides are different, scalene. Yeah, whether it's scalene, but the one thing we do know is that it's obtuse. And if ABD is an equilateral triangle, then angle 3 is what?
60.
Correct. Notice that says if. In other words, it doesn't really tell us that it is. It just says if it were, what would that angle be? If angle 2 and angle C are complementary, then what is a right triangle?
Would it be ABC?
Correct. In other words, you have to be able to see all three triangles here, which sometimes a little tricky. But there's that triangle, and then the big triangle. And those are the two acute angles of the big triangle, which makes it a right triangle. Find the values. This is good. I haven't had to write yet. This is the way geometry is supposed to be. Find the values of x and y.
Well, x would be 30.
Therefore, y is
60.
In other words, that's the two acute angles of a right triangle. And they're always complementary. Number 8. Which one do you have to solve for first?
Y.
Okay, it's correct. We have no way of solving for x. But once we solve for y, then we'll have two angles in that triangle and we'll be able to solve for x. So what's y?
60.
which makes x what?
90.
Correct. Number 9. Again, it's only one angle you can solve for.
X?
How would you solve for x?
Well,
You're right. You could solve for x. I didn't realize it until you just said that. So what's x?
could be
Something doesn't make sense in that picture.
45.
Now I know. You know, it's hard to solve for x. We know that x plus 20 has to be supplementary with 115, correct? Because they're adjacent angles of a transversal. In other words, they're side by side. If you look at x and 20 together, it's supplementary with 115, therefore it is 65, therefore x has to be 45. But that's not the way I would have solved for it. Here, I would have done this. Now, granted, there are many ways to do these, and there's no correct way, but I do think it's a little easier to solve for y first. Because anytime you have a triangle where they give you two angles, getting the third one is just a question of subtracting the sum of these two from 180. Remember I said that the magic skill to have in geometry is subtracting a number from 180? So y is immediately 45 when you do it that way. And now notice what x and y are relative to one another.
Yeah.
All
of them are
interior angles. Therefore, x is equal to y, and we don't have to do any math. Okay? Don't you think solving for y was a little easier? Because the other way we have to do it, we have to look at that angle there and know that it is supplementary with 115. Then you got to figure out x even after you figure that out. So it seems like there's a couple of more steps involved in solving for x first.
Yeah.
Okay, number 10, the measure of each exterior angle of a regular polygon is 45. Write the name of the polygon.
Well, they all have to equal 360.
Okay, so how many exterior angles are there going to
be 8.
Okay, so what kind of polygon is that?
Octagon?
Yep, a regular octagon. I'm glad they didn't give us a hard one because I don't know my names of all of them. I mean, I know decagon and duodecagon and things like that. Okay, complete the table for regular polygons. Well, this should be relatively easy. For a 9-sided regular polygon, what's the measure of each exterior angle? I hope you have your calculator in front of you.
Yeah.
Okay.
So, what is it again?
For a 9-sided regular polygon, what's the measure of each exterior angle?
It would be 40.
And the measure of each interior angle. It's a little harder. Give me the general formula for that. So useful general formula to know. In other words, this is the formula for the sum of the interior angles of all polygons, let alone regular ones. But since a regular polygon, all the angles are the same, then what are we going to divide that by to figure out the measure of each interior angle?
9.
N, yes. In other words, this is the master formula. That is the general formula for determining the measure of each interior angle for all 5 of these polygons we're going to look at here. So let's not erase that. Let's leave that up because we're going to find out that we're just going to plug into that for some of these. So what does that number equal? 7 times 180 all over 9.
7 times.
Must be 140.
Yes.
Because we had 7/9. 9 goes into 180 20 times 7. Okay, so now we have to work backwards essentially. So if the measure of each exterior angle is 15 degrees, how many sides does it have?
How many sides?
In other words, they're giving us row 2 and they want row 1 and row 3.
Would there be 24 sides?
And you got that by dividing 360 by 15?
Yes.
Now let's do number 3 and just use that formula.
Number 13?
No, we're going to finish number 12. In other words, we need the third row filled out also.
So it would be 22 times 180?
Divided by
24.
Right. In other words, we're just filling in. Once we know the number of sides, then that becomes a piece of cake. What is the answer?
165.
Okay, now it gets a little tougher. We know that 120 is the answer to this. So I can set that equal to 120, right? And solve for n.
Okay.
Now, algebra, the only reason that's a little tougher is because the algebra is a little... How would you solve that? We'll test your algebra skills here.
You would multiply that by n on both sides.
Okay, so that's 120n over there. And we still have n minus 2 times 180 over here. Now what?
Then you would...
Let's solve for n.
Well, first, can you just...
I have a general rule that works pretty well for solving equations. And it's not obvious to everybody. Everybody does the obvious. You do exponents first. But the two rules, the two things I hate to see in an equation are denominators and parentheses. So
yeah,
the general rule is I get rid of the denominators and then I get rid of the parentheses. Well, we got rid of the denominator in the first step. Now let's get rid of the parentheses. What does that give us? In other words, distribute that 180.
Yeah, so it'd just be 180n minus 360. No, yeah.
Okay, keep going. What's the next step?
Then subtract 180 from 120.
Okay, stop just there for a moment. When you reach this part of an equation where you have your variable on both sides of the equation, you have to make a decision as to whether you're going to put your variable on the left side or the right side. Correct?
Mm-hmm.
Now, I understand why you put the 180 on, wanted to move it over to the right side. The problem is you create negative numbers when you do that. negative coefficients. And negative coefficient, or negative numbers actually, are probably responsible for more mistakes in math than anything else. So I really kind of go out of my way to try to convince people to keep your coefficients positive if you can. Okay? Notice that if I subtract 120n from both sides, I'm going to have 60n. And then I got to move the 360 to the other side, and that becomes positive. Now I have two positive coefficients in place of what I would have had, which was two negative coefficients. And I understand they're the same thing, and maybe negative numbers don't give you any trouble, and if that's the case, well then this isn't particularly important. But, so n is 6, right?
Mm-hmm.
Okay, now we need the measure of each exterior angle of that six-sided thing.
Okay. Would that be 60?
Yes. In other words, it's 360 divided by that number. Whoop! I hate this. You think you're on the writing tool and you're on erase, and you just touch it down, it erases everything.
Oh, wow.
That you've put up there. Okay, so 14, we're going to have to do the same process we just did. Okay? Only this time I'm going to do it in the upper, no, I'll do it in the lower right. I'll just write smaller. So, here, let me let you do it from scratch. There is the formula for the measurement of each interior angle, if you know the number of sides. Well, we know the measurement of the interior angle, and we want to figure out the number of sides. So how do I go about doing it?
So you do that formula and it all equals 162.
Okay.
So then you multiply n on both sides, and it'd be n minus 2 times 180 equals 162n.
Okay.
Then you distribute n minus 2, and that would just be 180n minus plus 360. No, sorry.
It is minus. You know, I thought it was plus for a moment too. I thought I'd made a mistake on the other one, but that's multiplication there. That's not subtraction. Yeah. So, again, let's bring the n's to the left and the 360 to the right. So what's n equal to here?
So then just be 360 divided by 18. Just 20.
20. Yeah, I was just going to say, I can do that one in my head.
Oh, yeah, me too.
Okay. So, what's the measure of each exterior angle? Now there, put your calculator down for a second. I want to point something out. If 360 divided by 18 is 20, then what is 360 divided by 20?
9.
Has to be 18, doesn't it?
Well,
in other words, listen to what I said. I said if 360 divided by 18 equals 20, then 360 divided by 20 has to equal 18, right? In other words, here's my equation. 360 divided by 18 equals 20. Well, I can multiply both sides by 18 and divide both sides by 20, which gives me 360 divided by 20 must equal 18. So not only could we do it in our head, but if it had been a complicated number, we could have done it without a calculator, just by knowing that if that is true, then that has to be true. So whatever number you get right there is going to be the answer to the middle question.
But don't you use 180? Because it's an... Oh, wait, no, never mind.
Now, I got that by subtracting the 162n, so I had 18n. Just something I happened to notice that I thought I would point out is that there's a relationship. Notice what that relationship is. Notice what row 1 times row 2 is in every single case.
10? No.
360. 9 times 40 is 9 times 40 is 360. 24 times 15 is 360. 6 times 60 is 360. And 20 times 18 is 360. So what's the number of sides on this one? We don't have to do much math. I guess we'd do the same math as we would have done originally. You would have divided 360 by 30, and you get 12.
Yeah.
And then to get the interior angles of each one, now you just have to plug in 12 for n.
That'd just be 150.
Is that 10 times 180 divided by 12? Yeah. 12 goes into that 15. Yeah, it would be 150. Okay. Here, is that the bottom of the, no, it's not the bottom. Let me scroll down here. Well, a hexagon is how many sides?
6.
Okay. What's the sum? How do you solve this? 16.
You do a sub 1 or a sub n equals a sub 1.
No. 16 is merely they've given you 5 angles of a 6-angled figure.
Oh, so you just add them all up and see what's missing.
And subtract from what you have to calculate yet. So what's the first thing I got to calculate? The sum of the 6 angles. What is it again? What's the formula?
Wait, what?
We need the general formula for the sum of all 6 angles. I had it written up there before and I erased it. I'm glad I did because I want you to memorize it. And the way to memorize it is to keep giving it to me.
Over n.
That's the sum. That's not the sum. The sum of the angles is this. If it's a regular hexagon, then you could divide that by n and you'd get the measurement of each angle. But this is not a regular hexagon. So you can only divide by n if it's a regular polygon.
Okay.
Okay. Here you have to come up with what the sum is. Well, what do I substitute for n? 6. Okay, so now I got 4 times 180, which is 720. Now add those 5 angles up, subtract it from 720, and you got your 6th angle. That's 350, 490, 600. Is that correct? Did I make a mistake? first three numbers are 350, 490, and 110 is 600. So
Yes.
5 of the angles total 600. All 6 of them have to total 720. Therefore, the sixth one is 120. Like most geometry problems, you always have to figure out something else first. It's a little bit like those 5 problems in the table. We had to figure out the number of sides before we could figure out some of the rows. That's almost always the case. Just kind of count on it, that you're going to have to figure out something first before you can figure out the sixth angle directly.
Okay.
What's 17A? What are we plugging it into?
13.
Well, which formula are we plugging it into?
The n minus 2.
Okay, what do you get when you plug 13 in for n?
1,980.
1,180?
980.
Whoops. 11 times 180 is 1,980. Yes, it is. And what is the exterior angle sum of that 13-sided polygon?
360.
No matter how many sides. All right. On to this one.
Yes.
Okay. Classify each statement as true or false. There's at least one line through P parallel to K.
True.
I believe so. There's at most one line through P perpendicular to K.
True.
Yeah. Here, let me be able to write on here. In other words, I can draw one that's perpendicular, but I don't know any other way. In other words, that one's not perpendicular, that one's not perpendicular. I can only draw one line that's perpendicular to K.
So false.
What's that?
So the third one is false?
No, second one is true. Notice what the words are. There is at most one line through P that's perpendicular to K.
Yeah, and that's
I found that to be true. There is only one line. There's not two. There is at most one. Okay. You with me? See why that's true?
yes.
Okay. And 3, if J is perpendicular to K and N is perpendicular to K, then J is parallel to N.
False.
Oh, let's draw a line J. Okay, that's line J, and that's perpendicular to K. And then let's draw another line that's perpendicular to K that we're going to call N. If you have two lines that are both perpendicular to a straight line, then those lines are parallel. Notice why. We can treat line K as a transversal. In fact, if I extend J through there like that, then K is a transversal. And if a transversal makes two corresponding angles the same, then it means those lines are parallel. In other words, all of the theorems and postulates you had regarding parallel lines work in reverse also. By that, I mean that if I want to know if those two lines are parallel or not, and you give me a transversal and you tell me that 1 is equal to 2, those two lines have to be parallel. If 1 is not equal to 2, then those two lines are definitely not parallel. So it works both ways. In other words, you can't have those angles being equal and not have those two lines be parallel to one another. They would have to be parallel if 1 is equal to 2. Well, the same thing in our picture up here. The thing that looks like a chair, the 90-degree angle, those two angles are corresponding angles. And they're equal. Therefore, the two J and N is parallel. So all three of these are true. True, true, true. All right, let's look at number 4. Now I love these. These are pretty easy. In fact, you want to skip that and go on?
Yeah.
Okay, because I know you know how to do that. I've done this exercise with you enough times. Now, they could have made that exercise a lot tougher if they'd have made that transversal near perpendicular, right?
Yeah.
In other words, whenever they give you the question, they usually draw it at a pretty good angle, in which case you really have a severely acute angle and a severely obtuse angle, and then the problem becomes very easy. Number 5, if angle 4 is 40, then what is angle 6?
Angle 4/6 is 140.
And if angle 4 is 2x minus 7, and angle 8 is x plus 13, how do I solve for x? Give me the equation that I want to write.
It would be 2x minus 7 plus x plus 13 equals 180.
Are these angles supplementary or are they equal?
They're equal. Also
That's
equal.
all they are. In other words, there's only two conditions when you have parallel lines and a transversal. Two angles are either supplementary or they're equal. Well, if they're both acute, they're equal. If they're both obtuse, they're equal. If one is obtuse and one is acute, they're supplementary. That really is all you have to remember. Okay? And we can see that 4 is very much acute and 8 is very much acute. Therefore, they are equal. And I'm going to do that. What's the solution to that?
X equals 20.
Yeah. And notice I want to bring my x over to the left again. Okay. Here. We're going to 630, aren't we? Yeah. Okay. And we solved that, didn't we? You said x equal 20?
Yeah.
Okay, so what's the equation I can write for number 7?
Now these are supplementary.
Yes, because one's acute and one's obtuse.
Yes. 4x minus 7 plus x plus 22 equals 180.
All right, I'm going to leave it up to you to solve that. You've proven to me that you know how to solve equations.
Yeah.
Is that okay? And we'll go on, because there's a lot of material here, I believe.
Yeah.
We wouldn't want to miss our proofs either, huh? Right. a postulate or theorem that justifies the statement. And I guess I need the picture of the diagram on here. Huh? They are referring to that. Yeah, exercises 4 through 10. Yeah, okay. So what is the postulate that makes angle 4 congruent with angle 5? Now here's where you got to know what they taught you. In other words, here you can't use my simplified technique. You can't say they're both acute, unfortunately. What are they?
I don't know.
Okay, I'm going to give you the 3 types. There are 4 types of angles when you have parallel lines and a transversal. You have alternate interior, you have alternate exterior, you have corresponding, and you have side by side. And those are the only 4 that they make you memorize. So what are 4 and 5?
They're alternate interior?
Yeah, they're alternate because they're on opposite sides of the transversal, and they're interior because they're between the parallel lines. They're not outside the parallel lines. So that's alternate interior. And that's all you need to write, I'm sure. What makes angle 3 and 5 supplementary?
They're
Is that 4th one that I named? Remember, you have alternate interior, alternate exterior, corresponding, mean they're in the same position. 3 and 7 are corresponding.
yeah, so they're side by side.
Side by side, exactly. And that means side by side no matter which way you're looking at it. You can say 7 and 8 are side by side, 5 and 7 are side by side, 4 and 6 are side by side.
Yes.
All right, why is 2 congruent to 6?
They're corresponding.
They're gonna force you to learn that, despite my best efforts. No, actually, I think it's a good idea to learn that because you're liable to have a situation where you have this, and then it's not quite so easy to do it based on acute or obtuse. But you still would be able to do it. If you forget all of that and you have that situation, just make a slanted line and realize which angles are equal to one another and then apply it to the perpendicular. You know what I'm saying?
Yeah.
In other words, you could easily get by, even if I didn't know the 4 types of, or the 4 theorems, I'd still be able to figure it out because I would know that the position-wise, 1 and 5 are the same, 4 and 5 are the same, and 3 and 6 are the same. So I would just label the angles and figure it out that way. All right, let me scroll down again. What's X?
25?
No? Well, first of all, look at it.
Oh, I know. Y is 25.
Okay. But
And then
how do we know what X is without figuring out Y? Which theorem?
the theorem which states that like the interior angles.
It's in the exterior angle theorem.
Yeah.
In other words, X is an exterior angle, and therefore it's equal to what?
The two interior angles.
The sum of those.
Yeah.
And there's three angles in the interior of the triangle, but it's the sum of the two that it is not a linear pair with. Okay? So we know right away x is 155. Which makes y 25. And then you don't need to figure out y based on that. But so 12. What can we figure out first?
That one of the angles is a right angle, so it's 90.
Which one?
The bottom left one.
The 5x is a right angle?
Yeah.
Why?
Is it parallel?
Okay, good. So what's x equal to?
X equals 18.
Mm-hmm. Now what can you say?
3y plus 7y equals 180.
Good. That's a good way to do it. Based on parallel lines. There's multiple ways of doing this. You also know it's equal to 180 because you know that all four angles are equal to 360. Those two are already 180, so you know it from a number of different ways. So y is also equal to 18 because 10y equals 180.
Yeah.
Okay. Boy, they just beat you to death with this stuff, don't they?
Yeah.
Yeah. To be honest with you, that's the way to learn something. And they do a pretty good job at your school of doing that. Frequently, that's what I kind of don't get to do with students when I tutor online, because typically you go through a packet and they address this thing once or twice, but they don't give you 10 different problems to do that are all basically the same. You know, they don't give you a lot of problems to really let you drill with, but this one does. I'm impressed with this. So each exterior angle is going to be what?
360.
Each one of a 10-sided one.
Oh, 36.
Each interior is going to be. Ooh, they made a mistake here. The top line is a true statement. The bottom line cannot answer because they didn't tell me it was a regular polygon. Notice that if it is not a regular polygon, this question makes no sense. Each interior angle has a measurement. We don't know. We know what the sum of them are. We know the sum is 8 times 180, which is what, 1440? But if it's a regular polygon, is each interior angle divided by 10? In other words, 144 degrees. I'm sure that's the answer they're looking for there, but that's not really correct because that does not say a 10-sided regular polygon. And if it was not regular, that would still be true. Oh, no, it wouldn't. No, it wouldn't. You couldn't even answer number one, either one.
No.
Nope. Because if you had a 10-sided polygon that was not regular, the exterior angles would not all be the same. They would still sum to 360, but you wouldn't know that they were all equal. It's only a regular. They have to put the word regular there for either one of these questions to make any sense. If you want to impress the teacher, say unknowable. Seriously. Unknown. For that and that.
Okay.
She didn't put the word regular in there. Okay. Each exterior angle of a x-sided polygon has measure of 24. Now, the fact on 14 that each exterior angle has a measurement of 24 tells you it's a regular polygon, right? In other words,
Yeah.
if every exterior angle is the same, then every interior angle is the same, and that's kind of the definition, and all the side lengths are the same. So 14 is basically telling us that it is a regular polygon with that statement. Now, how many sides do we have?
22? No, 26.
How do you get it?
Because I know
What's the sum of all of them equal to?
360.
Okay, so what do we need to do?
Multiply that by 360.
Multiply.
Or divide.
Divide 360 by that.
Yeah, so that would equal
15. Right?
yes, 15.
Now you see why? In other words, if we had a 15-sided polygon, each exterior angle would be very tiny. It'd be like 24, and there would be 15 of them. 15 times 24 would be 360. So that's why, that's what we did in that previous problem with the table, is we always took 360 and divided it by the number of sides to get the measure of each, or the measure of each to get the number of sides. And each interior angle would have what? Tell me the master formula.
N minus 2 times 180 over n.
Now fill it in.
N would be 15 minus 2, so 13 times 180 equals
Over
13.
over 15.
15.
Remember, those two numbers are never the same, because one is n minus 2 and the other is n. N minus 2 just gives you the sum of the interior angles. But if you want the measure of each interior angle, you have to divide it by the number of angles there are. And that's n. That's not n minus 2. So,
Equals 156.
what is that?
156.
Okay. Oh boy, and we get arithmetic sequences too. All in one thing. This is kind of odd. Where's this coming from? Why would we jump from geometry to arithmetic sequences? Or actually, this is a geometric sequence. Have you been studying arithmetic and geometric sequences recently?
Yeah.
Oh, yeah? Recently?
Yeah.
Okay. All right. It's an odd place to put it. Usually that comes at the end of Algebra 2. So what's the next term? First of all, is this arithmetic or geometric?
Geometry.
Okay. What's common multiplier? What's R?
Plus,
What's R?
what's R?
R is the common ratio. That's what it's called. Okay? In other words, if I have a geometric series, then the nth term is always equal to the first term times R to the n minus 1. So R is a key thing. R is 2 divided by term 1. What?
For us, we only put the n minus 1 and not the R in parentheses.
Well, that's for an arithmetic sequence. It goes in parentheses. But for a geometric sequence, it goes as the exponent of r.
I guess we're doing the arithmetic then.
So you haven't done geometric, and yet this is a geometric sequence. This is not an arithmetic sequence. Arithmetic sequence is where every term is the same difference from the previous term. Whereas a geometric sequence is where every term is the same multiple of the previous term. No matter which two terms I choose, if I divide the second one by the previous one, I get r. r is minus 2. In other words, I get the 2 by multiplying the negative 1 by minus 2. I get the minus 4 by multiplying the 2 by negative 2, and so forth and so on. So what's the next term?
I have no idea.
Minus 2 times 32.
Minus 2 times 30, so negative 64.
Yeah, in other words, that's what r is. r is the common multiplier. So what's the next term after that?
128.
Yeah, positive. And you'll notice that it goes negative, positive, because the common multiplier is a negative number. That's the way they all come out, is alternating series. But this is your general formula for a geometric series. Okay? And here it is for an arithmetic series. You have a sub n equals a sub 1 plus a common difference times, and here's where your n minus 1 goes in parentheses. So this is the one you use for arithmetic sequences. This is the one you use for geometric sequences. Okay?
Okay.
And you could test this one out if you wanted to, easy enough. In other words, either one of these, if you forget what they are, what the general format is, we'll just take a simple sequence. What is the fourth term based on that? Better be 8, right? So yeah. If I want the fourth term, then it's the first term minus 1 times my common multiple, or r, to the n minus 1, the third power, because n is 4. That's the fourth term. Well, if I do that math, I get minus 1 times minus 8. When I cube minus 2, and that answer is 8. That's what my fourth term is. Therefore, that's the correct general formula. In other words, that's a great way to test whether or not you have memorized the general formula properly. And if you don't have a sequence you're looking at, just lay out one. In other words, 1, 3, 5, 7. That's an arithmetic sequence with a common difference of 2, right?
Yeah.
2, 4, 8, 16. That's a geometric sequence with a common ratio of 2.
Okay.
Okay? So that's the difference between them. And that is all that's on this page. Is that all of our pages, or is this one down here different? It is different.
Yeah.
Okay. So we got parallel lines, we got skew lines. Skew lines are not coplanar. That picture doesn't show it very well. In other words, you know what they mean by not coplanar? They're not in the same plane. If I took a piece of cardboard and I took a pencil and laid it at an angle to the cardboard, My pencil would be a skew line relative to the plane of the cardboard. The cardboard is 2 dimensions, but my line or my pencil goes in a 3rd dimension. That's a skewed line.
Yeah, okay.
Because if you have everything in one plane, then 2 lines are either parallel or they intersect. They have to. In other words, if we look at this top picture here where they're talking about parallel lines, well, if those lines weren't parallel, they would eventually intersect, correct?
Yeah.
The only time that's not true is if the skew line, if it's a skew line, if it's not in the same plane. I don't know how to draw it, so it wouldn't be in the same plane, nor did they. That's why it's not clear from the picture. But you need some sort of a 3-dimensional. In other words, if I had a line that was maybe coming down off the page and intersecting with my piece of cardboard right there, but this is a straight line, that's my pencil. See what I'm saying? That pencil would be a skew line to the plane MP. And therefore, it wouldn't have to intersect or be parallel with that line they show. In other words, that skew line misses that line. I didn't connect it because it misses it. It doesn't ever intersect and is not parallel. So, okay. Plane N is parallel to plane M if they do not intersect, similar to lines. All planes are either parallel or intersecting. If you had 2 planes of glass, you could set them up so that one was parallel to the other and they would never intersect, but any other arrangement, those panes of glass are eventually touching one another. That's why all planes are either parallel or intersecting. Okay, so now we get to the questions. Just a second, let me read that last one. Line parallel to a plane. Okay, that line Q that they're showing, that's outside that plane. That's not coplanar with plane N. Not if it's parallel. In other words, you can have a line that's parallel with a plane and it just never intersects the plane. It's like a skew line, only it's parallel.
Okay.
Okay. It's not coplanar. Okay, so number 1. 2 lines in the same plane are what? Sometimes, always, sometimes, or never. Oh, and they've answered all of these for us? Well,
I guess the answer.
Let's go down to where we have to answer. Time. Oh, actually, we're out of time.
Oh, okay.
So that's a good place to stop. We covered your entire first page.
Yes, thank you.
Yeah, you're welcome. No, you did good. That was this, and there were no proofs.
Yeah.
You did not have to do a single. All the proofs come at the bottom of this page. I noticed there are a few proofs, but we didn't. Yeah, here we go. But they've answered these also. There must be some at the very bottom that maybe not. What? Yeah. Okay. Maybe number 11 is a proof that you would have to do.
Oh, yeah. Well, no, it has an answer right there.
But that's good. It's nice to get a week's break from proofs.
Yes.
So I will talk to you next week. Oh, let's see. I am correct in that you wanted to cancel tomorrow night, correct?
Yes.
Okay. And then next week we're back on Thursday?
Yes.
Unless otherwise noted?
Yes.
See you next Thursday.
Okay, bye. Thank you.